Hi, good morning, everyone. My name is Richard Evans. I'm a product manager at Oracle Database Security, and I'm thrilled to be joined with my coworker and friend, Peter. Peter's the product manager of database encryption and Key Vault here at Oracle. So just to give you a safe harbor statement real quick, just the general idea is buy what we sell today. We may talk a little bit about futures, not really today, but make purchasing decisions based on what is available today. Just a reminder that this call is being recorded, and that recording will be available on asktom.oracle.com. We put current sessions as well as past sessions up there, so you can just go click on all sessions to view those previous month's sessions if you missed it. And if you're new, welcome. Ask Tom is office hours that are intended to give you a direct line into your Oracle database product development team. We start off each office hours with announcements of what's new, what we're excited about, or some useful information about database security. And we dive into a presentation on a technical topic. This month it's going to be TDE. And we finish with an open line for any questions you might have. So feel free to enter questions into the chat anytime, and we'll get to those during the Q&A segment during the later part of the office hours. Okay? We do this twice on the second Thursday of each month. These are identical sessions, so if you attend this one, you don't need to attend the other one. The only thing that might vary would be those questions, and we try to capture those from both and include that in the final recording we make available at asktom.oracle.com. All right, so some announcements here. Every month we mention it, but that's because we're excited about it. We've got Oracle Data Safe, and this product, unlike our on-prem products, it gets revisioned, it gets updated, how would I say that, every month, every 2 weeks. And so you'll see a lot of changes happening to this. So recently, we're rolling out this cool capability called private endpoints. And this private endpoints allows us to extend Data Safe to support database cloud services, Exadata cloud services that don't have public IP addresses, right? So if you're interested in testing this feature before it becomes generally available, please contact my boss, Russ, at russ.lowenthal@oracle.com. This release has better support for audit data containing very long SQL statements, so anything greater than 32K. And we've added a masking format called group-based masking. So that allows you to group masking together. So if you have city and state, city, state, and country, you can group these and mask these together. So some new capabilities out of DataSafe. This is a question that we've received a lot lately from customers, so we updated the documentation to kind of explain it better. If you have any questions about HTTP password verifiers, why they exist, how to remove them if you don't need them, go check out the Oracle Database Security Guide and dig into Appendix A. It's often overlooked, but it's a great reference for kind of understanding general overall security posture of the Oracle database. So Oracle, it's docs.oracle.com, select database, Oracle database, drill into security, security guide, and then navigate to the appendices and choose Appendix A. So take a look at that for HTTP password verifiers. All right, so before we get to the technical part of the session here, make note of these two My Oracle support notes, okay? So master note for TDE, that doc ID 1228046.1, and the quick TDE setup and frequently asked questions, doc ID 1251597.1. That way, as you go through your TDE implementation or your testing or what you're working on, you have these as a reference. We try to keep these up to date. These videos are going to be great, but these notes are good to have just there in the background. Okay. All right, today's technical topic is a second of our TDE advanced use cases. And we're going to drill in to our environment here a little bit. So I'll explain it, and then I'm going to turn it over to Peter. So Peter has got a 2-node rack cluster that he built using Tim Hall's Vagrant scripts. And if you've heard from Peter and I, we love these scripts. He's extended them a little bit for some patching and configuration. This is going to be a 2-node cluster with a unique name. So when you see it on the screen, you can kind of understand what it is. We've got node 1 on rack 12.2a and node 2 on rack 12.2b. Those are the host names. We've got one pluggable database there called FinPDB, like a financial database. And Peter's going to create some additional TDE-enabled databases using snap cloning. And he's going to do all this on 12.201 with the January 2020 release update. Okay, and you know we always want to show you the latest and greatest with 19C and talk about how fantastic that is, but we recognize there's a lot of customers that aren't quite there yet. So if you're not on 19C, right, we can show you what we can do with 12.2. But notice that Peter's using that latest January patch set. So that's the critical part, right? Please make sure you stay up to date on those patches. So even if you are running 12.201, we've got the latest and greatest release update there. So we get those bug fixes, security fixes, and everything with it. All right, today's scenario. Peter's going to set up a TDE with a shared wallet in ASM. So it's going to be TDE plus ASM with SQLnet.aura. And he's going to show you some of these new TDE-related initialization parameters you'll see in 12.1 and then 18 and 19 when you get there. So you're going to install that Key Vault client and migrate to Key Vault online master key mode. And he does it a really cool way with his automated deployment with REST services and things. So stuff that customers want to see. He's going to create and encrypt a PDB snap clone. So using Key Vault, and it's going to include bring your own key. So BYOK is bring your own key. If that's something your organization is looking at, Peter will show you how to do that today. Then he's going to prepare one of those PDBs to be relocated by exporting just that latest master key. So if you need to copy that environment from prod to QA or QA to non-prod, after you've masked or removed some of that sensitive data, he's going to show you how to relocate that pluggable database. And if that wasn't enough for you, it's going to show you an additional feature or capability here that you can do with Key Vault. It's encrypting sensitive data with ACFS and then using Key Vault to manage those volume keys, right? So lots of good information. I've tried to put some arrows in the video. We recorded this as a video so we could cut out some of the reboots and things that happen, the not switchovers, but the some of the configuration that we just didn't need to sit here for 30 seconds or so looking at. So, all right, let's get to this. I'm going to share my video. And then, Peter, are you able to unmute yourself?
I'm muted, I think. Can everybody hear me?
You are. I can hear you. All right. So without further ado, here's Peter Wahl to take over.
All right, good. So what you can see on the screen here is my terminal window showing the two rack instances. On the left tab, we have the instance A and instance B on the right tab. The database haven't been started, so there's still, the database is not running. And I just make sure that all the settings that we need to enable TDE are there. So there's one thing that you need to know. The grid infrastructure ignores environment variables, and TDE in database versions before 18, they need those environment variables. Grid infrastructure ignores them. That is why we need to set those environment variables in server control. So with the next command, I create a shared wallet directly in ASM, and I add the TDE settings into SQLnet.aura. And of course, that needs to be done on both sides of the rack database, right? So in node 1, node 2, and then I confirm that my environment settings are there, and I start my database. When I do that, that takes much longer, but I think Rich shortened that process a little bit.
Yeah, that's the magic of the recording. Yep.
Yeah, exactly. So I would like to add that my database wasn't running, and I'm starting it after I made the changes to AskTOM Office Hours. if your database was running, you have to bounce it, because the database doesn't capture changes to SQL.Aura unless it's a single instance database, right? A single instance database, you just log out and log back in, and then it gets it. RAC databases, they don't do that. You have to restart for the database to pick up the changes that we made to SQL.Aura. Okay, here as a first step, we create a key store in our shared in the shared directory. That was that command, create key store, and then the next one is we set the oh yeah, of course we have to open the key store first. Yes, we open the key store, and then we set the key, but only for the root container. I'm doing this because I like to tag the keys that belong to my PDBs, and you will at the end see why I'm doing this. So here I could do administer key management, set key identified by password, and then container equals all. That would create a master key for the container and the pluggable database, but the PDB key would not be tagged. So here I have a SQL statement that generates a tag. You see, it contains the name of the PDB and the timestamp. And so now I'm copying this command from my terminal, and I will have a key in my PDB that I can easily find afterwards. Imagine you have an Exadata system with hundreds of PDBs and they keep on rekeying. You will be glad if you have tagged your keys with the name of the database and the timestamp, which makes it really easy to filter those keys in OKV. So that was that. Now we close the key store and we create an auto open wallet. In RAC, you really want to have a shared auto open wallet, because if you don't, it's very inconvenient when your RAC instances, when they come back after they went down for any reason, if they're auto started. And then if you have a password protected wallet, or if you have an individual wallet, that's even worse, because then the TDE events are not synchronized. So you really want to have a shared wallet in ASM or in ACFS, and it should be an auto open wallet. So now we can go ahead and we can encrypt the user's table space of our root database. And we do that online, so there is no downtime. And we do the same thing with the user table space in our PDB. So that, as I said, it can be done online. And here we have a setting that makes sure that all new table spaces are always encrypted. So imagine you have an application that installs a database application, and that script creates table spaces. Then most likely that script doesn't have the encryption syntax with it. So in this case, all those table spaces that the application creates will be created encrypted from the beginning. So that's what you do with this new system parameter. Oops, that was quick. Okay, so yeah, so now we create a table space without the encryption syntax, and in the alert log we can see that this table space has been encrypted with AES-128. That's hard-coded for now. In later database versions, starting from a 19, you can tell your database which key it should use by default when you don't specify a key. But here for now, this is hard-coded, and this was encrypted with AES-128. So next step is we create a table in the encrypted table space, which is a copy of DBA objects, so that we have some crypto work to do. And then I changed the encryption of that table space to AES-256, because most customer security policies tell the DBAs that they have to encrypt everything with AES-256, so that's what we do here. And then we finally select from the encrypted table. We do this on both nodes just to see that everything is working as advertised. I should be switching over to the first node and select from my encrypted table, and that should work. So all good. Because we have an auto open wallet, there's nothing else you have to do. Your table spaces are encrypted, your data is safe, and there's nothing to worry about, oh, I need to know the wallet password, whatever. So now we go ahead and install the OKV client. For this, the OKV administrator, which is me in this case, the OKV administrators have prepared a set of scripts for the DBAs. And we will go through the steps, and I will show what's in those packages in just a moment. So I download a lead version into my first instance, and I unpack, and I see that I have 2 wallets in this package, and a configuration file and a file called runme. So if we look at the configuration file, you see we have a server address. That is the IP address of my OKV server. The REST admin user is a user in OKV that has the system administrator and key administrator privileges. The next 2 lines are the log files, and then the last line says client wallet, and then it points to the path where I unzip this package. The configuration file contains a username, right? REST admin. And the configuration file allows for a password to be put into this configuration file, but who would put a password into a configuration file? So what the OKV administrators did, they create a wallet, and those are the 2 wallets that you see in this package. You see wallet.sso and ewallet.p12. Those 2 wallets contain the password for the REST admin user. So the DBA who runs that script, the script logs into OKV and executes the command that we see at the end of the screen. And still the DBA doesn't need to know the password for the REST admin user, right? It's hidden in those 2 wallets. So when the DBAs download this package, they all download the same, right? It's all the same package that they download. So we need to make sure that the wallets and endpoints and everything that is created in OKV has unique names. And that is why I have a script that is called runme. And that runme reads environment variables, and with these environment variables, I can build the wallet name, the endpoint name, and all these things. And that's just one example. You can be creative to any degree that you would like in terms of naming your objects, but they should be unique. And then if we execute runme, this creates a script that is referenced in the configuration file. The configuration file has a line that says script equals home oracle script.txt. If you move up a little bit to the middle of the screen, yes, there, that's where the mouse is. That's where you can see that's the script that we just created from the runme, right? The runme creates that script. And so here we see we create a wallet and we create an endpoint, and one of the most important things is that we associate the wallet with the endpoint. Right? We have a 2-node rack system. We will have 2 endpoints, but only 1 wallet, which means that both instances have access to the same key material that is stored in that 1 wallet. And the provision command does 3 things. It configures the OKV client, it downloads the OKV client, and it installs the OKV client. So after that, you're done. You just run the script. So here in the next step, we create a directory that will hold the OKV client software installation, and then we execute the RESTful API and give the configuration file that we download, that we open from the zip file. So here the RESTful API creates a wallet in OKV. And that next step always takes a little bit because there are certificates involved, and that takes a little bit. So we create an endpoint, we associate the wallet with the endpoint, and then we download and install the OKV client. There's one last thing you have to do. You have to run a root script which installs the PKCS11 library into the directory where the database will find it. So the root script copies the PKCS11 library and makes adjustments to the privileges for this file. And there I confirm that my database can actually find the OKV client installation, because this whole thing that we have done on that first database instance until now happened outside of the database. So my database doesn't know that we installed the OKV client. Could you go back real quick to the end of the left window, please? Okay, a little bit forward, a little bit more, all to the end. I know it's complicated. Okay, so we create the script, and then with this a name I. A name I is a program in Linux that follows soft links. And here I confirm that the Oracle database has created a soft link that points into the installation directory for the OKV client. And that is how the database is able to find the IP address of OKV server, the username, certificates, everything what it needs to talk to OKV. Okay, so now please continue. So now we would do the same thing on the second instance.
Yeah, I think I fast forwarded to the second instance.
Oh, you're already done. Oh my goodness. Okay.
Yeah, okay. I think I got a little bit ahead of us here. Sorry.
Okay, so while I wasn't watching, Rich installed the OKV client on the second instance. We're already done. You notice that everybody who downloads that package has the same password. You see that in the line provision and then -v. That's the password into OKV. And for now, of course, because all DBAs download the same thing, everybody has the same password, and we will take care of that later. Mm-hmm. Now, in the RunMe, you see that I mentioned that I downloaded the lead version into my first instance, and here I will download the secondary version of the script, where we don't see a create wallet line. It's only a create endpoint, but the magic happens in the next line where we do the set default wallet, where we associate the second endpoint with the wallet that we created in our first instance. So here again, it becomes clear that both our rack instances have access to the same wallet. So now I have a question for you. What would you do if you have a 4-node standby and a 4-node primary database? How many endpoints do you have, and how many wallets?
Oh, I don't know, man.
You're all muted. Sorry.
No, you're good. Yeah. You're putting me on the spot.
You would have 8 endpoints and 1 wallet.
Mm-hmm.
So all the instances of your primary database and all the instances of your standby database would connect to that one shared wallet. Mm-hmm. So here we have only 2 endpoints with the 4-node primary and the 4-node standby. You have 8 endpoints, and they're all attached to this one wallet. Mm-hmm. Okay, so then we install the software and we run the root script, and the next step will be to validate that the soft link has been created and we are successful. So now we are done with installing the OKV client. Let's take a look what that did in OKV. So if we go and check for the wallets, we see a wallet name called SFO-RAC. That's the wallet that our script generated, and it associated the 2 endpoints with that wallet. And if you click on endpoints, we see that, let's go down, search. Okay, we see that the second endpoint hasn't been replicated yet. So this is a 2-node OKV cluster, and we create everything in the first instance. So you see that the second wallet is still replicating to the second OKV instance. The important part is that our wallet is the default wallet of both endpoints. And as you can see, everything is correctly set up in OKV, and that was done by a script without the key administrator doing anything. Right? The DBAs can do that themselves. So the next step, I believe, is we change the password. And we would always like to, yes, we change the password. We would always like to implement separation of duties between the OKV administrators and the DBAs. So if it's basically the same example that I had last time when I showed you, when I guided you through the data card setup, where that was a request from a customer who asked me for a scenario where they can basically, the security operations team has access into every Oracle server. And they said that I should imagine that the DBAs go home on Friday afternoon and then they take over and implement the OKV setup, and they don't want the DBAs to mess around with OKV. And that is why we can imagine that the OKV client installation was already done by the security operations team. They can do that remotely. They have access to all those database servers. And so they download the script that they maybe even generated themselves, and they install the OKV client with all of them having the same password. So that's why the security operations team, the next step they do is they change the OKV password. And we've done this on the first instance. Did you already do it on the second instance,
Yep.
Rich?
Yeah, we've got it done on both nodes now.
Oh, good. You're too quick. Okay, so we changed the passwords. That's good. And now, before we migrate our keys into OKV, one very important, unique thing that you only can do with Key Vault is you can upload the wallet into Key Vault. And we do that before we migrate. Because if you look at the PCI standard, they don't allow you to have encryption keys on your database server anymore. So before you migrate, meaning before you tell your database to no longer talk to your local wallet, but use OKV for key management, before we migrate your database, we upload the wallet into OKV. So all your old keys, if you have an old database, an old 11G-R1 that was upgraded to 11G-R2 and then 12.1 and now 12.2, you have hundreds of keys in that wallet, right? And we want to upload them. The wallet is in a shared directory in ASM, and unfortunately, the OKV util command doesn't understand ASM. So in this case, the trick is we create an empty wallet in some directory, and then we merge the content of the shared wallet into this new empty wallet that we just created. Right? And then, so now that temporary wallet in temp has all the key material from our shared wallet in ASM. And from there, from that wallet in the temp directory, we do the next step, and we upload the keys into OKV. Right, so it's OKV util upload, type is wallet, location is temp, and the group, meaning the wallet name, is SFO-RAC, right? So that asks for the source password and for the OKV password, and then everything that's in OKV, in the wallet, it's not only encryption keys, it's also metadata that helps with TDE internal householding. So that is why we list keys 2 or 3 times. You don't have to worry about this. You need to know there are 2 different keys in this case, and they're both uploaded into OKV. And then we can remove that wallet again because we don't want keys lying around on the server. And now we go back into OKV again and click on the All Items view and click on, because this is one of the world's oldest OKV. It's my private demo environment. It has over 4,000 keys. It has been upgraded from a 12.201 3 years ago. So And here we see the keys that we created, and you see the tag. So the tag replaces the key ID in OKV. If we don't put a tag on your key, you see the key ID. If you tag your keys, where did you go? Can you bring the browser back for a second? Okay, thank you. Okay, so if you don't tag your keys, you see the key ID. If you tag them, you see the tag. And so here we can clearly see the tag FinPDB with a date stamp. That's the key that we created in the wallet and just uploaded into OKV. And that belongs to our financials PDB. Okay, please continue. Okay, so now that we uploaded the wallet, the next part is that we get ready to migrate that database into OKV. For this, the next part, I believe that I'm entering, okay, can you pause quick? With this command, we enter the new OKV password that the DBAs don't know into our old TDE wallet in the shared directory. Why are we doing this? Because I mentioned to you that you always want auto-open connections into all your key stores, right? We already have an auto-open wallet from earlier, but we also want to have an auto-open connection into OKV. By adding the OKV password into the TDE wallet, your RAG database, which we have to shut down and restart in a couple of minutes, will find all the keys and will come up without problems. If you don't have an auto-open connection, you will have problems bringing your database back up. Specifically, if it's a RAG database, if they don't find keys, it can get really nasty. So you always want an open. You always want an auto-open connection into your key stores. So, okay, can we continue, please? So that here we added the OKV password into the old TDE wallet. Okay. Next one. Okay, so now we exit, and that's a trick that comes from the 18C and 19C databases. If you have worked with TDE, you know that we need the wallet password or the OKV password in the administer key management command line. So there's no way for us to hide the OKV password from the DBA. That is why we invented another wallet, and that goes into a specific directory with a specific name. And again, we insert the OKV password into just another auto-open wallet. And this wallet is used to hide the OKV password from the DBAs, right? The first wallet that we created, or the first command, we added the password into the OTDE wallet. That gives us an auto-open OKV connection. That second command adds the same password into another wallet, and the database looks into this wallet if we set the next parameter, which we need because 12.2 databases don't know wallet root. Right? In wallet root, that is something that we introduced in Oracle 18 and 19 that replaces the dependency on secretnet.aura. And if you use wallet root, you don't need that parameter. This external key store credential location is only needed for a database that doesn't know what wallet root is. So now the database knows where to find the OKV password when a DBA issues an administer key management command. Okay, so the database is ready to be migrated. Now we need to change AskTOM to point to OKV and still to our file because we are migrating. So for the migration step, the database needs to know where OKV is, how to reach OKV, and it needs to know where the wallet is with the old keys. So now we made two changes that require a restart. Right? The first one that requires is the external key store credential location. That's a static parameter that needs a restart. And then, of course, the changes to astronet.aura. That also needs a restart. Here I'm copying the ID of the wallet that I created in OKV. I copy that ID, and you will see in a moment why I did this. So here we restart our database, and while that database is restarting, I believe that I go to the second instance. If you continue, Rich, yes. I go to the second instance, and I use the RESTful API to confirm that my wallet is ready, that it's active, that I can actually migrate my database into OKV. If you imagine that you have a gigantic enterprise with 10,000 of databases, and at one point they all rekey, they create new endpoints, they're active in OKV, OKV gets busy and there can be a delay. Sometimes it's up to 2 minutes before that object is replicated to the second node. And that is why we have those new commands that let you query the object status. Right? And only when you do this on both instances, and both instances tell you it's active, that's when you can start. That's when you can migrate. Otherwise, what happens if you migrate and your wallets are not ready? Your database will migrate, but your keys in OKV will not be associated to a wallet. This is something that can be fixed, but why would you do that, right? I mean, we can always move keys around, we can put them into wallets. Nothing is lost. It's not a catastrophe, but it's an unpleasant experience. So it's easier if you make sure that your wallet is active, and then we can go from there. So we restarted, we confirmed our wallet is there, and now we migrate to OKV. And because we migrate from a shared wallet, both instances, instance 1 and instance 2, will migrate to OKV. If you have individual wallets, right, I mentioned earlier that we highly recommend to use a shared wallet. If you have a rack system with individual wallets and you migrate, only your lead node migrated. And getting the other nodes to follow what the lead node has done, meaning you have to restart all your nodes just one more time. All the other nodes, not the lead node, but all the other nodes need to go down and need to get up. So here in the alert log, we see right now highlighting the confirmation that our container database has been migrated, and shortly after we see 2 more entries from our pluggable database telling us that we switched for the new master key in the HSM. So now our database is talking to the HSM. So what we do here, hold on, Rich, can you stop real quick? We delete, and I can firmly see how some of you start cringing now, but we delete all the keys that we had. We deleted the old wallets. We delete the auto open wallet. We delete all the keys, and we didn't pay attention. We also deleted the OKV password that was in the old TDE wallet. But the problem that we fixed is we don't have any keys left on your server. That's one thing. The bad thing is that we just deleted the OKV password from your wallet. But not to worry. In 12.2, we allow you to create, you've seen that 5 minutes earlier, we allow you to create standalone auto open wallets. And that's what I do next. So I basically fix what I broke here. So with the next command, I log into my database, and what is this now? Oh yeah, that's the migration step. And here we add the OKV password back into the wallet. So we create an auto open wallet that only contains the password. We don't have any encryption keys left on our server.
Okay. All right, now we're back in the pluggable database.
Mm-hmm.
I press play.
Oh, yes. I mentioned to you that we would like to tag all the keys, right? And you notice that in the beginning, when I created this first key for the pluggable database, I used a tag for this key. Now, when we migrated, we created two new keys in OKV, one key for the container and one for the PDB. So for that key for the PDB, we would like to add a tag afterwards, so that we know that this key belongs to the PDB, and oh yeah, by the way, that's the first key that we migrated. So we know that all keys that are older in OKV have been uploaded from a wallet. All keys that are newer than this one have always been created in OKV. And if we go back to OKV real quick and reload the all items page, then we can see that we just added a tag to the key, right? It says FinPDB first migrate. And that's the tag that we added. Okay. Okay, so this is all done. We added a tag. Good. So now the next step will be, now we start, oh yeah, this is bring your own key. Bring your own key honestly only makes sense when you implement separation of duties. So in this case, this command could be executed on the computer of the key administrator, not the DBA, right? The only thing that the key administrator needs is he needs the OKV client installed, and then he can create such a script, and it creates a key identifier and an encryption key. And then I built a script, or I built a command that contains all the upload things that I need to upload that key into OKV. And this can still be done by the key administrator. So now if I'm the key administrator, I copy the key identifier, the name of the key, and send this over to the DBA. And then the DBA can issue a use key command, and then the database uses that key without the DBA ever seeing the key itself, right? The DBA knows the key ID, that's fine, that's the name. And if we do that use key command, then we have to prepend 06 in front of the key ID, because 06 are keys that we have in OKV. 01 are keys that come out of a wallet. So that is how we know internally where our keys come from. So now the key administrator gave that key ID to our DBA, and the DBA can tell the database, okay, so now you use that key. And as you can see, we replaced the password that was needed in the back, where we said, where we usually say a fourth key store identified by password. We now say identified by external store. So our DBAs do not know the OKV password. We have an auto-open connection into OKV. We just confirmed this because we bounced our database, and we can still select from our encrypted table. Okay, I believe the next part is that we will create snap clones. Okay, so for snap clones, in order to do snap clones, we need an ACFS file system, which I created earlier. The mount point is called snap clones, to make it obvious. And that's the file system that we will be using for snap clones. Now, before you when you do snap clones, the source database of those snap clones need to be in read-only mode. Now, you cannot copy from your production database, because you cannot put your production database in read-only mode. So what 12.2 allows you to do, that if certain conditions are set, then you can clone a live pluggable database. And for this, we need to check if, oh, that was this one. Okay, let's fix this. Yes, so now the database creates files in snapshots. That's one thing. And we need to validate if we have online, oh God, what was it again? Online local undo and archive logging must be turned on in your container. And if this is the case, then you can make a live clone, a hot copy of your production database. So here I create a pluggable database dev master from our production database without taking it down. Key store identified by external store. So because there is key material involved, I need to take care of this. So now I created a pluggable database dev master. Dev master is a clone of our FinPDB and firmly believes and is correct in a certain way that, hey, I'm the original because, you know, I'm a clone. I'm exactly like the original. So that dev master still uses the same key that FinPDB used. That is why the first thing that you do after you, come on. Oh, there is a little hiccup. I think I need to log in twice to get this auto open connection to work. There we go. So we have an auto open connection into OKV. That part works. But we also need to set a separate key that belongs to that database. And we do that again with tagging the key. So we know that this key belongs to DevMaster. And now DevMaster has its own encryption key. And we still can select from our encrypted table. That hasn't changed. Okay. So now the dev master wasn't a snap clone. That was a normal copy, a normal full clone. This is our source for the snap clones. And this is why dev master needs to be open read-only. In read-only, we still can select from our encrypted data. There is a little hiccup with the auto open logit. You have to try it twice to make it work, but then it opens. So this database is open read-only. And now we can create a snap clone. So there you see the syntax snapshot copy. And key store, again, identified by external store. Whoever, whatever DBA does that command, he doesn't need to know the OKV password. Okay, so now we created a pluggable database, a snap clone for developer David. And we open that database, and also that's a clone from dev master. So dev David believes that, hey, I'm the original. So this one is still using the encryption key that belongs to our master copy. So now we log into dev David, and again, we have to do this 2 times. There seems to be a glitch in our software. Okay. And after that, we set our key for this database. So then, and again, we tag it. So we know that this key belongs to developer David. Okay. So now we see that our dev David has its own key. And we still can select from our encrypted table. That hasn't changed. So I think the next part will be that we create a wallet. Yes, perfect. So let's imagine that Dev David has completed his development work, and now the pluggable database is moved over into QA. So we create a wallet in OKV called Move David QA, right? Very obvious. So we move Dev David's PDB over into another container, and the wallet that contains the encryption keys is called move David to QA. So again, we check if our wallet is active, right? And that's a unique wallet. Unique wallets are created much easier or much faster than normal wallets, but they change their name. So we have to find the object name, and there we see that OKV added underscore OKV01 to our planned wallet name. So that's the next part, the first part. The next part is we give our endpoint read-only access to this new wallet. Right? So there is, yeah, exactly. There's a command add wallet access endpoint, and now we go check our wallets, and there we see a new wallet, move David to QA, and that's already active. And now we only want this one key that belongs to Dev David into this wallet, so that because the encryption key needs to move with your database, right? And the key moves with your database. And if we can download only that one key from that one PDB, then we don't have to worry about that the keys from a production database suddenly end up in the development environment. So here we can clearly identify the key that belongs to Dev David, put this key into the wallet, save our changes, and go back to our command line after we move the terminal windows out of view. Okay. And now we can download this one wallet that only contains the keys of Dev David. And then we can unplug the PDB and move that PDB someplace else and give that wallet with the PDB, which then can upload into the target OKV, and everything is good. Okay, so now we downloaded the key into the wallet, and if we do an mkstore list, then we see that there's only one key. 3 entries again, but that's our internal householding, but it's only one key. Right? That's the key that belongs to Dev David, and that wallet can travel with your PDB to whatever container you need. Okay, so that was this part. I believe the next part is ACFS encryption. Yes. Okay, so we can encrypt the ACFS file system. So if your application stores sensitive data in ACFS, if we have an application that writes out information, God knows what it is, log files, audit, whatever it is that is sensitive and doesn't fit into a database, you can encrypt the ACFS file system. And the first step you do is you initialize the encryption. That's our first command. And then you need to export OKV home, because we execute those commands as root. Root has no idea about environment variables. And the -e parameter checks for the export for the external file. And here the password that we're prompted for is the OKV password. Right, so we type in our OKV password, and from that moment on, ACFS talks for OKV. And we can confirm this with the next command, because the next command tells us that key store OKV. Right, so again, we manage the encryption keys of databases and ACFS file systems. So now if we do an OKV util list, we go check if we have a key, and there's one key with a horribly long key ID. And that's the key that came in from ACFS. So now that we have the keys established, yeah, exactly. We encrypt the file system, the directories, and the files in those directories. right? And they are encrypted with an AES key with a key length of 128 bits. Here I rekey to 256 bits, right? So you can rekey. It's the same thing that you can do in an Oracle database. You can rekey the data encryption keys. You can rekey the master keys. So here we rekeyed the data encryption keys, and now we rekey the master key, which of course prompts us for the OKV password, and that re-encrypts the file encryption key. And if we do an OKV util list again, we see that we have a second ACFS key in OKV. And so now we have two of those really long names. So those are the keys that come from the ACFS file system. So I believe that concludes.
Yeah.
Oh yeah, and there's a summary on how the encryption looks like.
Yeah, very cool. And that's neat. I didn't know about that until we talked about that, but just that capability with ACFS and Oracle Key Vault, huh? Very cool. Okay, so we're almost at the top of the hour. Next month, the second Thursday will be on March 11th. We're tentatively talking about Database Vault again because we realized we kind of missed something basic here of enforcing trusted path access to data. So we'll probably do that one. Let's go ahead and go to a Q&A here. Peter, we have one question here in the chat. And a tool says, so if I want to use XSCS on OCI and want to use our own keys, then we create keys in Key Vault in OCI and then install the OKV client, or does XSCS come with the Oracle Key Vault client?
Can you quickly tell me or tell us what database version you have? Because there is maybe there can be a much easier answer than this. So if you are on Oracle 18 or 19, you can also bring your own key into the wallet.
Oh, he might have had to drop off because I don't see a tool on there now.
Oh.
But can you kind of give us a quick difference? I think you started to, or I cut you off.
Yeah, so here in this example, I uploaded my own key into OKV, right? Starting with Oracle Database 18 and of course 19, you can bring your own key and put that into the TDE wallet. So you don't need to have OKV. But here, to answer the question, we want to use our own keys when we create keys in Key Vault in OCI. Yeah, so in this case, you run your Exadata machine is in the cloud. You have Key Vault running in the cloud, and then you install the OKV client. And the Exadatas they don't come with the OKV client. You install it yourself. You can use the RESTful API to do this on hundreds of your databases if you have so many, right? And then you can either have your database create the key, or no, that's not true. If you use OKV, then OKV creates your keys, or if you don't trust OKV, you can bring your own key. That's up to you.
Yeah. Cool. Okay. Well, thanks. All right. We've got about a minute here. If there's any more questions in the chat. And then Roman had a comment. He says, thank you very much. And if you have any blog about this, please share it.
Yes, I do. I actually wrote a blog about bring your own key maybe 2-3 months ago. It's out on blogs.oracle.com.
Oh, great. Perfect. All right, let's go ahead and open it up in the chat and the QA. If you have any questions, please feel free. We've got Peter on the call now. So Peter can handle any of your TDE, Key Vault, ACFS encryption related questions.
Yeah, I'm happy to. And thank you very much for taking over. I had the fun of my life joining the web conference.
Isn't that always the worst, where you're panicking right before a presentation and your technology isn't working? You know, it's the demo gods, right? They they couldn't get you because we recorded the video, so they got you with your laptop. That's what they did. So, yep.
Yeah, but thank you very much for jumping in and taking over. Thank you.
Yeah, you're welcome. Yeah, you're welcome.
Rich, I'm not seeing any questions in Q&A.
Yeah.
I've gone ahead and given everyone permission to unmute themselves if they want to, but so far, no questions.
Yeah. When either we did such a fantastic job that there's no questions, or we just flooded them with so much good information that they're gonna have to sit back and go, all right, let me wait for the video to get to Ask Tom, and then I'll analyze the video, and then I'll pester Peter in a day or two. So. Mm-hmm. Okay.
Right, and Sue, apologies, I was trying to unmute you and somehow I managed to promote you to panelist, so please don't pick anyone off.
Yeah. So Peter, we have a question from Dennis here. Are there any plans to enable old export functionality with TDE table spaces? And Dennis, can you clarify what you mean by old export functionality? Because I'm thinking the old export import.
Yeah, so I think we only support data pump when it comes to encrypted data. The old export and import tools don't understand encrypted data. And so very early on, when at 10GR2 times, I believe, or maybe 11GR1, we decided to let only data pump handle encrypted data.
Yeah, and there's so many advantages, Dennis, about data pump export import, the ability to get the status of it, to resume it. There's a lot more metadata, a lot more like, I don't want to say where clause, right? But a lot more granularity with it that you can build in with data pump.
Can you hear me?
Yeah.
I'm asking that because we have some old applications that we can't convert, or it's pretty involved. So I was asking that so we can't go to Oracle Cloud, or we can't enable TD table spaces that customers are asking us to use without going to data pump. But so that will be pretty involved for this application as well.
Yeah.
So in the Oracle database 18 and 19, the RMAN team has picked up TDE a little more than before. There are new commands. You can do RMAN duplicate encrypted or restore encrypted. So maybe you can take a look at this. Maybe that helps you.
RMAN?
Yes, if you do an RMAN backup, it can be exported as encrypted, basically on the fly.
Interesting. Yeah, I'll have to take a look at that.
Mm-hmm.
Yeah, that might be a possibility. I have to take a look at that. It might be easier to implement than data pump in that application.
Yes.
Yeah. And at some point you're going to have to bite the bullet, sir. You're going to have to upgrade to data pump, or find something else there, I think, because
the without getting into too much detail, it's an application that has been deployed to thousands of users in probably almost 1,000 customers throughout the world. So it's
it's challenging. Yeah.
It's the other challenging part with data pump is it goes to the server when they export it, which is probably the more secure method of doing it. So, but with export, they can export all the projects to a client, and we'd have to still support something like that for these customers, or a lot of customers.
Okay.
So yeah.
Yeah, no, I get it. Yeah. So feel free to email us, and if you have any questions that you don't want to ask in an open forum. So.
Okay.
Yeah. Thanks for the question, Dennis. Okay. All right. We are at the top of the hour here. I'm going to go ahead and stop the recording and.